and record. The way I run my classes is usually I will go ahead and share my screen and we'll start in a PowerPoint. Okay. It's a little bit maybe unconventional for a math class to be taught through a PowerPoint, but basically we're going to be jumping from the slides on the PowerPoint um, back and forth to a piece of paper where we work out some examples, just so that as we're having this conversation, you guys are able to ask questions and I'm able to clarify any confusion. There's going to be some vocabulary here. There's going to be some example problems that we work through, but I want you guys to be active participants in this class session. So what that means is if you need to unmute yourself and interrupt me to ask a question, please do so. If you don't feel comfortable interrupting me, um, then please put a question in the chat. Although I will tell you that once I get going, uh, sometimes I neglect to look down at the chat button. So if you see that somebody has asked a question in the chat and you feel comfortable interrupting me, then go ahead and do that to help out your classmates, okay? All right.
Oh,
So
Mr.
what's up?
So I found out a way to like type in stuff on the document.
Okay.
It's just the only issue is that, say, for example, like 5n squared, 5n to the power of 2. I can't type in the power of 2, the exponent, if you
Okay,
will.
so I'm gonna have to pump the brakes on that conversation, Ian, because that's like a really personal conversation that once we get to the worksheet, I'll put you guys into breakout rooms and then I'll try to address that question specifically. Okay. Because like
Okay.
I can't manage everybody's different device and everybody's like document management, whether you're trying to type something on the Word document or whether you're trying to type something on the PDF. It can be kind of confusing, but I just want to go ahead and get the ball rolling here, okay? So there will be a time and a place for that worksheet, and we will get to it and work on that together towards the end of this PowerPoint. Okay, can you guys see this slide all right?
Yes.
Okay, let me
Yes.
just, and I'm just double checking. I am recording, so I will put this recording up later. Let's get going. Today, what we're going to be talking about is evaluating functions. And like I said before, there's going to be a lot of vocabulary here. You need to think about math as a foreign language. So I'm going to give you some vocabulary, and then hopefully we're going to have some opportunities to practice using that vocabulary. Okay. So the first thing that we need to talk about are algebraic expressions. Okay. Um, Algebraic expressions are a statement that combines constants and variables with different mathematical operations. So right away, in that sentence alone, we have some vocabulary here that we need to be aware of. One, we need to understand what a constant is. We need to understand what a variable is, and we need to understand what is meant by operation. Okay. Because a lot of us have been out of school maybe for a few or even several years. Okay. Maybe even a couple of decades for some of us. Um, so does anybody here know what is meant by constant?
Numbers?
Yeah, numbers. That's a perfectly fine definition for constant. A constant is just a number when it's written down, you know what that value is. For instance, if I were to write down the number 3, well, presuming that, you are in the United States or an English-speaking country where that symbol is universally understood to represent three things, you can count that value. You know what that value is. Okay. So can anybody tell me then if we know what a constant is, it's just a number, you know what they look like, you know their value. Can anybody tell me what a variable is or what you think a variable is?
It's like the unknown.
Yeah, that's exactly right. I think that's a really concise definition. It's the unknown. Okay. So I like to think about it this way. A constant's a number, its value is apparent, which means you know what it is by looking at it, and it's fixed, which means it's not going to change. Okay. Because it would be like really difficult to like communicate with people if, you know, I looked at the number that we all understand to be a 3, but I said, oh, it's actually the value of 5. We're going to change its value. We're going to leave the symbol alone, but change its value to 5. That would be really strange. Um, and really confusing. Okay. So we don't ever do that with constants. We know what their value is. But the reason why we in algebra start putting letters into certain mathematical expressions is because we need a placeholder for something that's unknown. Okay. So a variable is just a number, but we don't know its value. And as a student in a math class, usually the instructions of the problem that you're working on or your instructor, right, your teacher will tell you the value of X is blank, and they'll tell you what the value is. Okay. But until that point, you don't know what its value is. Okay. So an algebraic expression is a statement that combines constants, variables, which are usually represented by letters, and mathematical operations. And for now, we can just think of those operations as being addition, subtraction, multiplication, division. Some of us are familiar with exponents, but down below, I have an example of an algebraic expression. Okay. If you were to read this out loud to yourself or to a friend, if you wanted to annoy them, you would say, I have 2x plus 3y minus 10x plus 4y squared, or sometimes we just say 4y to the second power. Okay. So given these definitions, right now I can tell you that there are four terms in this algebraic expression. Can you tell me, are there any constant terms in this algebraic expression?
Is it the 3y and the, oh no, the 2x and the 10x?
Okay, so you're looking here at the 2x and I'm going to circle the negative 10x.
Oh, yeah.
It's
But
3 and 4.
I kind of have an idea of what you're thinking here, but these are not constant terms. Okay. So basically, the way you can think about this or identify which ones are the constants are if it has a letter attached to it, if it has a variable attached to it, it's not a constant. Okay. So if I were just to ask you point blank again, we have four terms. We have 2x, we have 3y, we have the negative 10x, we have the 4y squared. That's four terms in this statement. Are any of those four terms constants?
No.
No. Okay. None of those terms are constants because they all have a variable or a letter next to them, right? Or attached to them. Okay. So that means that all four of these terms are variable terms. Does that make sense?
Yes.
Okay. Now, the reason I think students get confused about variables is because we use letters to represent them. Usually, mathematicians really like the letters X, Y, and sometimes Z. Um, but let me just have you guys think about this problem. Okay, this is like a thought experiment. I just want you to think about it. You might go with a friend to the movies, assuming that you're in a time machine and you go back to like 1995 when maybe the movies cost $5 for a ticket, right? I've gone to the movies recently and it does not cost no $5 to get into the movies anymore. But you have a friend and they want to see this movie, but they're a little bit short on cash and they ask you to borrow about $5 so that they can get into this movie, right? If they ask you for about $5, how much money are they asking you for?
$5.
It's unknown.
So I like the $5. I like the it's unknown. They're not being clear about what they're saying, right? They're being kind of vague. What does about $5 mean? What that
Maybe
means
just like 1
is
to 5.
Somewhere
could,
around there.
it could be $5 flat. That's possible. It could be a little bit more. It could be a little bit less, right?
Because have some money.
Right? They might have some money also, right? We want to set that aside. Let's assume that they don't have any money, but they're saying like, oh, the price of the ticket is maybe it's $5.95, right? and they just tell you about $5. What we want to understand as mathematicians is like, or like as math students, is that it is not clear how much money exactly they need. We know that they need $5, but it might be more, it might be less. Okay. So one way that you might describe this using math is to write an expression down like 5 plus x, right? Because that x is a placeholder that's going to take care of whatever the remainder is. If there's extra change that you have to pay, it's going to go in there. So the x here represents the unknown amount, which if it was negative, would mean that 5 plus a negative amount would be a little bit less than 5, right? Because like adding a negative is like taking away money. Or it could be positive, in which case it would be 5 plus some positive amount, maybe some change, right? Or it could be 0, where it's 5 flat. But we just don't know. What we do know is that based on what they said, we know that the constant is 5. Does that make sense?
Yes.
So like I hear this all the time, students every single semester, and I've been teaching here at St. Philip's for 8 years now. Students are always saying, I understood math until they added the letters in. Okay, and then everything got crazy. And yes, it looks complicated when you have letters in there, but it's really to represent a very common problem. Like if I were to go to the gas station and say, oh, gas is like 2.90 something, I'm gonna round up to 3 to cover my bases because like I don't care about the details. I know that 2.90 something is close enough to 3, right? So we're always playing that game with numbers where we say, and this is close enough. But for this class, we're gonna eventually start playing a game where we have to solve for that missing piece. So when we start solving equations and solving for the variable, that's what we're doing, trying to solve for that missing number. Okay. Okay. So there's some more vocabulary here that we have to be aware of. And one vocabulary term you're going to hear me say a lot is coefficient. Okay, so coefficient refers to the number in front of the variable. So here's an example. I have, 3y. Okay. And the implied operation that's happening here between the 3 and the y is multiplication. Okay. So whenever you see something like 3y, you need to think to yourself, this is the number 3, which you know, you can see it, times some unknown, right? Some unknown value. And it might seem weird that you can take an unknown value and multiply it, but we do this all the time. I like to tell my students, like, I'm really enjoying Cosmic Crisp apples. If you go to HEB, there's a bunch of different varieties of apples, and Cosmic Crisps are some of my favorites. So I go to the store, and I know I want to get 5 of them. I could represent that by drawing. Here's my terrible drawing of an apple. There we go. Got the little stem, got the little leaf, right? And I could draw 5 of them and write 1 apple plus another apple. Here, that's 2 apples. I'm getting lazy, so I'm just going to say, I just want to get 3 apples and get out of the store, right? So there's my 3rd apple. Okay. Well, I wouldn't tell my friends if I was speaking plain English. Oh, I went to the store and I got an apple, and another apple, right? That would be a complicated thing to tell them. What would I actually tell them to make it simple?
I got 3 apples.
I got 3 apples. And so the coefficient, instead of saying I got an apple, and an apple, the coefficient is just a counter for how many of those apples you have. So I could just write this as 3, and then I just need to write the apple symbol once. Okay, that's a terrible apple, so bear with me. So there's a couple of ways to think about this. One, if I have 3y right here, That's the same thing as saying I have y plus y plus y. But why would I do that? Because that's more complicated, right? Just count the number of y's and call it 3y. That's way simpler. Okay. Now, when I say, oh, 3y is actually the same thing as 3 times y, it's because we have 3 times whatever this object is that we're calling y. In the same sense that, like, if you had, back in elementary school, you guys learned multiplication as repeated addition. Let's say I had 5 plus 5 plus 5. Well, that's the same thing as 3 times 5, right? So that coefficient is just telling us how many 5s we have. Okay? So that's a couple of ways to think about it. And I'm just trying to dispel this idea, this notion that it's crazy to have a placeholder. Because when they're pictures, when I draw pictures of apples, it seems like this is baby math. Like that makes sense. But as soon as I replace that with a letter, students start to like their eyes glaze over and they're like, I have no idea what's going on. But it is very simple, okay? Don't let the letters scare you. Things will get a little bit complicated later on, but for now, that's the definition of what a coefficient is. The number in front of the variable tells you the number that's being multiplied by that placeholder, or how many copies of that placeholder we've counted. Does anybody have any questions or comments there? Okay.
No.
Moving along. There is one note that we have to make here, and it's something that confuses students a lot. If I have a variable, let's say I just have the variable x, how many x's did I just draw?
1.
Yeah, just one. So when a teacher tells you x is the same thing as 1x, or sometimes they say x has an understood coefficient of 1, that sounds confusing. But if we're just using plain English and I'm talking about apples, if I had an apple, how many apples do I have?
1.
Yeah. And I didn't say a number, right? I said I have an apple. But you guys understand that if I have an apple, that's the same thing as one apple, right?
Yes.
So it doesn't matter what the variable is. It could be a w. If I ask you what's the coefficient on the variable w, it's 1. 1w. How many w's do you have? You have 1. Okay. So moving on. Variables are just placeholders. It doesn't matter how crazy or complicated an algebraic expression looks. They're just placeholders. They work like other numbers. We just don't know their value yet. Okay. What we're going to learn how to do is evaluate some expressions. That is, eventually, I'm going to give you some problems where I tell you what is the value that we're going to plug in for x, and what is the value that we're going to plug in for y. That's what I mean by evaluating an expression, right? We're going to plug in a number, and then we're going to, quote unquote, solve the expression. Okay. But sometimes you're going to get problems where the variable value is not going to be given, in which case we need to understand how to simplify an expression even when the variable value is not given. Okay. So to simplify expressions, and I'll hang on this slide for a little bit while if you guys need to write it down, but the steps are very simple. There's really just 2 steps. One, when we say simplify, we mean that we're trying to make the expression look less complicated. Okay. In the same way that, I said I was going to go to the store and get an apple, an apple, an apple. It'd be simpler if I just told you I'm going to get 3 apples, right? That looks and sounds less complicated. Okay. When you have an expression like the one I have on the screen right now, we want to make it look less complicated. And so there's 2 things that we want to do. The first thing is apply the distributive property, which some of you guys might have heard about. but we're going to have an example where we use that. And then if you distribute everything out, you've probably heard the expression combine like terms. Okay. What that means is that any of these terms in the expression that has the same variable and the same exponent, those are like terms. Just like when I said apple, 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 those are like terms. We can combine them to say 3 apples. If I have x, 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 and y, 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 then I can combine my x's because those are the same variable, and I can combine my y's because those are the same variable. Okay? So here, looking at this expression, what are my like terms?
The 2x and 10x?
Yeah, almost.
It's negative 10x.
Or negative 10x.
Yeah. So
Yeah.
one trick that I did when I was in high school that always kept me on track was, you can use different colors. I used color pencils back in the day. Now I sometimes just, if I have a black pen and that's all I got, I'll just use a shape and I'll box in the term as well as the sign in front of it. Okay. So we know that this is a positive 2x. We know that this is a negative 10x. Okay. So think about it this way. We're trying to combine the x's. So what we're talking about is like the apple example. We're talking about apples. So if we're counting apples, then we can just talk about the numbers and then we'll talk about apples later. So if I have 2 and minus 10, what is 2 minus 10?
-8.
Negative
Yeah.
8.
Negative 8, right? So you're going to put this as negative 8x. Okay. So when you combine these two guys, they become negative 8. Are you guys okay with that?
Yes.
Okay. Then, are there any other like terms that we could combine, possibly?
No.
I heard a no. Does anybody want to argue?
Possibly
It wouldn't be
3y
possible.
and a 4y squared, because you have 2 y's, so maybe you could split the y.
You're talking about this y over here?
Yeah, the y squared,
Uh-huh.
and then the 3y.
Yeah.
Um, can you add the, well, I mean, you are adding them, but
Like combining the coefficients?
yeah.
So in this case, you can't. Okay. Or in this case, you don't really want to. So when I say combine like terms, you have to remind yourself that you want to look at the same variable, but they also have to have the same exponent in order to combine them. So for our purposes, this 3y is not the same as the 4y squared. They're different. Okay. So we don't want to combine those. Instead, what we're going to do is just put the 3y down, unchanged. We didn't do anything to it. And then we're also going to bring the 4y squared down. And we're not going to do anything to that either. Okay. Because those are not like terms. Any questions, comments there?
Nope.
Okay. So that's pretty much it as far as combining like terms is concerned. This would be your final answer if I said simplify this expression. Because there was nothing to distribute. You don't usually with the distributed property, you see parentheses and you have to multiply some stuff, but none of that was going on here. So all we did was combine like terms and then we call it a day. And I think that one thing that a lot of students have trouble with is knowing when to stop. Okay. So always just do that checklist in your head. Do these guys have the same variable? Do they also have the same exponent? Then combine their coefficients, right? And if there's nothing else to combine, for the love of God, stop, okay? Because a lot of times students will get the right answer, but then they panic and they think like, oh, I must have to do something else. And they force themselves to do some extra stuff and then it messes up the correct answer. Okay. So really learn to be patient with yourself and learn to like stop and walk away when you're like 80 to 90% sure that you're done. Okay. And that's going to be hard to learn how to trust yourself, but with some practice, it'll be fine. Okay. So here's some more examples. Okay. Just so that you can see them, if I need to throw some up on paper, we can do that. X plus X equals 2X. Are you guys okay with that?
Yes.
Yes.
Okay.
Yep.
If I have 5P plus 7P, that equals 12P. Does that make sense to you guys?
Yes.
Yes.
Okay. If I have 10C squared minus 12C squared, that should be negative 2C squared. Are you guys all right with that?
Yes.
Yes.
Okay. Anybody not all right with that? And please speak up if you're not sure about one of those. Okay. So like, again, just to give you guys some tips, like as somebody who's been doing this for far too long, I don't even look at the variables. If once I check that they're like terms, I just think of this as like 10 minus 12, right? I do 10 minus 12, I write down the negative 2, and then I ask myself, okay, what was the variable again? C squared, got it, right? That's it, okay? So when combining like terms, you're essentially just adding and subtracting, or adding or subtracting rather, the coefficients, but the variable symbol stays the same. Okay, so when we say combining like terms, that's the same as addition or subtraction. Okay. So here is a slide on the distributive property, just to get us going. Distributing, or the distributive property, is just a fancy word or fancy phrase that mathematicians use to describe multiplying. Okay? So think about this. I sometimes bake not fancy things. Usually if my bananas are going bad, I make some banana bread. Or banana muffins rather, because I need to get new bread pans. But imagine that you're baking a pastry and you get the recipe. It calls for 5 eggs, 6 cups of flour, and maybe a cup of water. And this most disgusting pastry that you've ever heard of. Okay. If those are the only ingredients, I'm sure it doesn't taste good. But you want to double this recipe. Okay. Well, you guys know intuitively that doubling means multiply everything by 2, right? That makes sense?
Yes.
So as a mathematical or an algebraic expression, you might write the number 2, and then in parentheses, you put your ingredients. You got your 5 eggs, you got your 6 cups of flour, you got your 1 cup of water, right? So if I needed to take this 2 and I wanted to multiply 2 times the 5 eggs, what should I end up with?
10.
10 what?
10
10E.
10E, right? Or 10 eggs, right? That makes sense because I'm just doubling it. Okay? But when you double a recipe, you have to double every single ingredient in the recipe, right? So now we're going to do double the 6 cups of flour. So how many cups of flour should I have now?
12F.
F.
12F. And we're just going to bring down that plus sign. And then finally, we're going to double that 1 cup of water in this most disgusting pastry. And how many cups of water do we have now?
2.
2.
2W.
2 cups of water or 2W. Yeah, that's right. Okay. So when you're distributing, you just take this number that's in front of the parentheses, and it might be a little annoying, but you just need to multiply it by every single term that's in the parentheses, which means that you're multiplying this number by whatever coefficient you see inside that parentheses. Anybody have any questions? And then remember, if you have 2 times W, that's the same thing as 2 times 1W. So that's why 2 times 1 stays the 2 down here. Okay. And I have these animations in the PowerPoint slides, so we might as well use them. There we go. Okay. Any questions, comments, concerns about combining like terms or the distributive property? Would you guys like me to make up some examples on the fly to work on? Or do you want to hold off until we get to like the worksheet at the end?
Hold off to the end.
Okay,
Yeah.
sounds good. Yeah, I think that it's really good to get through the content and then we'll get to the worksheet and get that practice in and then we'll see how we go from there. All right. So another big thing that you guys are going to be doing in this homework assignment and throughout the semester is evaluating expressions. So this is where we're going to give you an expression. You guys might think of them as equations, but we're actually going to tell you what the variable value is. Okay. So if we know what the variable value is, what we're going to say is plug in 2 for b, right? So thinking about this expression, I have b squared minus 4b plus 10. Okay. And, the way I think about this in my head, and again, I'm a seasoned veteran at this, I always think, oh, okay, plug in, that makes sense. I'm going to take this. I know b is equal to 2. So I'm going to plug it in here. I'm going to plug a 2 in here. But often I think as math educators, we forget that you guys are coming from different backgrounds and different experience levels. Okay. So I want to give you guys some steps for evaluating expressions that you should always follow. Okay. Always write it down this way. When you are asked to evaluate an expression or plug something in, what I'm telling you is first, write the expression and replace the variable with an empty set of parentheses, right? So I'm taking the b out of the expression and I'm just putting an empty set of parentheses wherever there was a b. Because I said before, the variable is just a placeholder. So we're going to put those parentheses in place. And now the variable was a placeholder for what value? Well, in
2.
this problem, it's 2. Yeah. So I'm going to plug in a 2 right there. And I'm going to plug in a 2 right there. Okay. Now I say plug in, but you're going to write that down, right? And if you've written it down with the parentheses and then you plugged in the number correctly, then all we need to do is grab our calculator and the calculator will do most of the work for us. Okay. So I am going to switch over to my document camera right now just because I think it's worth seeing this written out. I think sometimes you lose stuff whenever we're looking at just animations on a PowerPoint. So here we are. I said we want to evaluate b squared minus 4b plus 10 when b is equal to 2. And step 1 is always to rewrite that expression, but we're going to put parentheses squared minus 4 times b, so in parentheses, plus 10. Then I can come back in and I can plug in 2 since that's the value of b. Okay. Now, at some point this week, or hopefully, I know that you guys have said that a lot of you guys are going to pick up a calculator from campus. When you start really getting into the thick of math, this is going to be your best friend because there's a lot of tips and tricks that we can do in the calculator that will make this easier for us. In this class, we don't have the time to go back and reteach order of operations. It's assumed that if you're in this college level class, you know PEMDAS, you can do parentheses, exponents, multiplication and division, addition and subtraction, right? And you can do that faithfully and always get the right answer. But what I find is that a lot of times the assumptions that the school makes, putting students in these classes from all different kinds of backgrounds, all different schools that have different quality levels, I can't always ensure that you guys will do this by hand correctly. So the calculator is the best way to go. Step 2 is going to be just type into the calculator exactly what you wrote down with the parentheses and all. So if I, for a moment, hopefully you guys can see this, I'm going to turn in my calculator, parentheses, 2, close the parentheses. Okay. I don't know if you guys can see this. Let me see if I can turn on this light. It's a little bit brighter. I'm going to raise that to the second power, minus 4 parentheses 2, close the parentheses, plus 10. Okay. Is that exactly what I wrote down? If you can type that into the calculator exactly as you wrote it down and hit enter, it'll do the work for you. Your answer is 6. Okay. So when it comes to like showing your work on tests, if you can write this out correctly and then plug that into the calculator and you get a 6, I'm fine with that. Okay. Because otherwise, the long way would be exponents 2 to the second power is 4, and then minus 4 times 2 is 8, plus 10. Then you would do 4 minus 8, which is negative 4, plus 10, which is going to be 6. And you can show these steps, but it's not really necessary. When we get to test number 2 and test number 3, the problems that we're going to be looking at are going to require you to do this over and over and over again, evaluate these expressions. And if you're wasting your time doing these little steps by hand, you're going to get lost in the sauce and you're going to get so confused when we get to the harder stuff. Okay? So I want you to, if you haven't already gotten a calculator, make sure that you schedule some time, come to campus, grab one of these TI-84 calculators, and practice using it. Okay? Because it's going to make your life way easier. Okay? Especially when we get to later tests. Does anybody have any questions about the calculator or this calculation that we just did?
So you're saying when we do the test, as long as we write the problem out the way you have it wrote out, and then just plug it into the cap. Okay, I got you.
Yep, absolutely. Right? Like for this first test, it's going to feel like, oh, this is incredibly simple. I can do some of this in my head, or I can do some of this by hand. And that might be true. But like it's going to get more complicated come test 2, 3, and 4. And so I need you guys to be training and practicing using this calculator. So many times, and I'm not sure if I told you guys this yesterday, but I have a lot of students that they check out a calculator and then I work with them in math world or in class and I'm like, dude, where's your calculator? You checked it out. And they're like, oh, it's in my backpack. I don't know how to use it. Well, you got to learn how to use it because it is going to be your best friend, especially when we start doing harder things like typing in fractions like 1/2. We can do fractions in the calculator, right? And I can multiply that by 5 to the third power if I wanted to. Really crazy things in this calculator that are made so much simpler if we can just type them in, okay? And as we get to those things like typing in fractions, I'll start to show you guys like, okay, to get the fraction, you do this, but we'll cross that bridge when we get there. But exactly right. Just want to reiterate the answer to your question. If you write it down exactly the way I wrote it here and then type that into the calculator and get your answer, that's good enough for me. Okay.
So for exams, we can use the calculator.
Absolutely.
Okay.
Yeah. So for the exams, you have to use one of the sanctioned calculators for this class, the TI-84 models, or if you have a less powerful calculator like the TI-30XS, which is a scientific calculator, that's permissible as well. But you cannot use your phone. Okay. Just because your phone is not only a calculator, it's phone a friend, it's the internet, it's Google, it's ChatGPT, it's all of these things. So again, to cut down on the risk of cheating, you're only permitted to use one of these calculators, the TI-84 or a lower model. Okay. But yeah, you can use a calculator on tests 100%. This isn't like grade school where we're going to be like slapping your wrists with the or slapping your knuckles with the ruler if you are using your calculator. Like long gone are those days. You need to use your calculator because we're going to do some heavy lifting later on in the semester and you gotta be fast at it, fast and accurate. Okay? So we plugged in the number, we solved or evaluated the expression, and that's it. That's all we're going to be doing. So, like for this next example here on this slide, it says evaluate the expression with a is equal to -1.1 and b is equal to -2.3. So if we needed to write this out, like I said, anytime you need to evaluate an expression, rewrite the expression, put an empty set of parentheses, and then what's going to go in the parentheses next to the -5?
-1.1.
Yeah, -1.1. Right? And what's going to go in the parentheses next to the 4?
-2.3.
-2.3. Right? And if you plug that into the calculator exactly the way you wrote it down, hit enter, you'll get this number, right? It's a god-awful number. And with these decimal numbers and these negative numbers and these exponents, things start to get crazier. And so what you want to be able to do is just going back over here to the calculator, right? You want to just be able to write this as -5 times -1.1 squared plus 4 times -2.3 to the third power, right? And ain't nobody got time to do this. It's a negative times itself, so that's a negative times a negative, and then 1.1. Do you guys remember how to multiply decimals by hand? Some of you might, but it's kind of a convoluted process. And so, like, if you get something crazy like this, or something even crazier, like let's say I had to plug in a fraction, like 2/3 or 7/8, that's going to be an impossible task. Not impossible, but very difficult, right? Let's just grab that calculator, make it our best friend. I typed in -5 times or parentheses -1.1, close the parentheses up. I have an exponent of 2, so I'm going to put to the second power plus 4, parentheses -2.3, close up the parentheses, put a third power on that. And I know there's a glare a little bit, but there we go. All of that stuff is stored in the calculator exactly the way I wrote it down. You hit enter, and this is the exact same number that it's on the PowerPoint slide. Does anybody have any questions or comments here?
No.
Okay. So I put this in the calculator. If you put, calculator because you're like, oh, I don't want Mr. Aguilar to think I cheated, write calculator down. That's fine. I don't care. You can write me little messages on your work. -54.718. And that's it. Move on with your life. Okay?
Mr. Aguilar,
Yeah.
how'd you do the negative? Because every time I try to put like a negative on mine, it just says ANS minus.
Do you have this TI-84?
I have the exact one.
Okay. So that issue is because, and this is a good point. On this TI-84, you have two buttons that look like subtraction. This button over here on the right above the addition sign, that's your true subtraction button. This number down here, that looks like
I see.
parentheses with a negative, that's a negative symbol.
I
So
just want to type out the problem.
yeah,
See if I can
you
get
don't
the
want to
right
confuse it. You want to put negative parentheses -1.1, right? Plus 4 parentheses -2.3. And I already forgot my exponent, so I'm going to back up. And I'm going to insert an exponent there. And I'm going to put my exponent on that one. Okay.
And for the exponent, where'd you find that?
The exponent button is this little button that looks like a rooftop or a little arrow up. It's
Okay.
right underneath the clear button.
Carrot.
Yeah. People call it a carrot, but I heard somebody pronounce it carré, like it's a French word, and I'm not sure. And now I don't know what to think about anything. Once I heard that, my mind was blown and I just lost it. But yeah, this is called the caret button or the carré button. I just call it the exponent button. Okay. And if I have some time, maybe I'll make up a little like an info sheet for some of these calculator buttons just to clarify where they are and what they do. Okay.
That would
What's
be
the
awesome.
what's
I
the
totally
negative
got the wrong,
2.3?
that what?
Where the calculus kind of like blocking the 3, I can't tell what's in front of it.
Uh, hold on, I
Uh,
totally typed in that problem incorrectly. Behind the 3 or in front of the 3?
it's like +4, and
Plus
then
4?
parentheses -2, and then it's like blocked off. I can't tell.
It says 0.3.
And that's it. You close it off, and then
I close off the parentheses and I put the third power. And then that should be the answer, right? I did it
yeah, that's what I
incorrectly
got.
above. Yeah. Okay. So I don't want to spend too much more time on that particular problem. It's going to be a little bit of a trial and error there as you guys get used to that calculator. But the only way to master it is just to start practicing, right? And that's what the homework is for. So let's move on our discussion here so that we can get to that worksheet sooner rather than later. Okay. There is one thing that kind of confuses students, and that is sometimes when you multiply variables together, the variable exponent changes. Um, that doesn't happen when you multiply a variable with a constant. Okay. So think about this example. If I have two apples that are in a recipe, maybe I'm making an apple pie or something, like a personal apple pie that is fairly large but requires two apples. Anyway, weird example. I want to triple this recipe. So I'm just going to multiply it by 3. Okay, so if I have 2 apples and I multiply it by 3, I get 3 apples. I'm sorry, I get 6 apples total. Does that make sense?
Yes.
Yes.
Okay, so if I have something maybe a little bit foreign, like I have 5z to the third power, and I multiply that by 8. Okay, 5z to the third power. Does anybody want to venture a guess as to what they think the answer is going to be here?
$48, or
Wait,
maybe
can you repeat that?
I said 48. I don't know. I think I multiplied that wrong.
Yeah, it's a little bit off. You're close. So, does anybody else want to venture a guess?
40.
40z cubed.
Yeah, 40z cubed, right? So think about this z cubed as like your apples, right? All I really care about is multiplying that coefficient by this constant 8. So 5 times 8 is 40. And then I'm just going to keep that variable, which happens to be a z to the third power or z cubed. And that's it. That's the same thing that we did here with the apple with the 2 times 3. And then we just put that variable back in place. Okay. So when you multiply a constant times a variable term, and it doesn't matter what that variable term happens to be, it doesn't really matter what the exponent happens to be. If I had 10y times 3, well, then that should be 30y. Does that make sense?
Yes.
Okay. So you don't want to overcomplicate it because sometimes I do see students that they'll do the 5 times the 8 in this example, and then they'll say, oh, but what do I do with this third power? Do I do 40 to the third power next? And no, you don't, because if you did that, you're completely neglecting the z, right? The z to the third power is a whole thing, and we can't do anything with that until we know what the value of z is. Okay, so just leave it as z to the third power. You're just multiplying the coefficient by whatever the constant is. Okay, questions, comments there? Okay. So here's some examples just to maybe make you think a little bit more about this. Can you guys simplify the following? What is x plus x?
2x.
2x. Are you guys okay with that?
Yes.
X squared.
Ooh, incorrect. It is not x squared. So remember this, when we're adding, that's the same thing as combining like terms, right? So when you're combining like terms, it's like going to the grocery store and saying, oh, I have an apple and then I have another apple. How many total apples do I have? So that's 2 apples in this case. So if I have an x, that is technically 1x here, 1x there, and 1 plus 1 is 2. And we're talking about x's, so that's just 2x. Okay. Can you guys tell me what 2y minus 2y is?
0.
Ooh, so let me maybe put it in the chat if what you think your answer is there. I heard 2 answers. I heard 0, and I think I heard 0y. Okay. And okay, so I'm seeing 3 answers in the chat. I'm hearing y, 0y, or just 0. Okay. Now, in math, there can only be one answer here, at least at this point in the class. Okay. So let's think about this. When you are adding like terms or combining like terms, you either add or subtract those coefficients, right? So the coefficient here is 2, and the coefficient here is minus 2. So what's 2 minus 2? Feel free to unmute yourself.
0.
0.
0. Okay. 0 what? What's the variable?
Y.
Y.
Yeah.
Y.
You could write this as 0y. That'd be perfectly fine. Okay. However, in a previous slide, I said this coefficient and this variable, there's an operation that's implied that's happening between them. Do you guys remember what that implied operation is?
Multiplication.
1.
Multiplication, right? So what is 0 times anything?
0.
0.
0. So like y is just a number. We don't know its value, but I know that if I multiply that by 0, my answer should just be 0. Okay? So your final answer here which should just be 0. 0y would be acceptable, but to really simplify it, it's just 0, just the number 0. Okay? Does anybody have any questions? Does that make sense?
Got it.
Okay. Now, I do want to clarify here because some people think, oh, 2 minus 2 is 0, and then you have a y left over. So why isn't the answer just y? Okay, so for a moment, let's just erase this here. Let's say that you put y as your answer here. If I have just a y, what's the coefficient?
A 1.
1.
It's an understood 1. So if you tell me that the answer is 1y, what you're telling me is actually that 2 minus 2 is equal to 1. And that's not correct, right? So you have to be careful there because 2 minus 2 is definitely not 1. It has to be 0, okay? So whether you put 0y or whether you put just plain old 0, that would be correct, but don't make this mistake, okay? If you have 0 y's left over, you have 0, okay? A couple more brain teasers here. What do you get when you simplify the following? X times x.
X.
X squared.
There
Or
we would get, yeah, there we would get x squared or x to the
oh,
second
X.
power.
Oh, it's multiplying. Duh.
Yeah, because we're multiplying, right? So think about it this way. For those of you that were like x times x is got to be x, right? Is 5 times 5 equal to 5?
No.
No, that wouldn't make any sense, right? You can't multiply something by itself and then it stays the same unless it were 1. 1 times 1 is equal to itself. So in that case, maybe if x is equal to 1, then x times x would be equal to 1. But that's a very weird scenario, right? What we need to understand is that that's going to be x squared. Okay. And exponents track how many repeated multiplications that we do. Here's a little bit more of a challenge. 2y times negative 2y. What do you guys think the answer should be?
Negative 4y squared.
Yeah, there we go. Negative 4y squared is perfect. So you multiply the coefficients. 2 times negative 2 is negative 4. And then y times y is y squared, where the exponent is just a convenient way of writing repeated multiplication. Okay. So, we've talked about a lot of things here, and it's really just to jog your memory about some of these ideas from grade school. Like, for instance, for exponents, we should understand that an exponent is just a way of writing repeated multiplication. So if I had like b to the 1 power, the exponent is telling me that I have only a single copy of b. Okay. That's multiplied by itself. Well, it's only one thing, so no multiplication is really happening. Okay. But if I have b squared, or b to the 2nd power, then I should have 2 copies of b, right? If I have b to the 3rd power, then I should have 3 copies. Or for those Spanish speakers, 3 copias. No, I'm just kidding. But yeah, exponents are just a way that we don't have to write things out. So if I'm saying I'm multiplying 5 times 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 5, wouldn't that be annoying as hell? Right?
Yeah.
To write out all of those 5s, right? So instead, we're going to condense this and say, okay, that's 5 repeatedly multiplied how many times? Well, let's just count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And so 5 to the 9th power is way more convenient to write down than writing a bunch of 5s out. Okay. So that goes for variables as well. If I had x to the 2nd power, how many x's have been multiplied by themselves?
2.
If I had x to the 47th power, good Lord, would you want to write that out by hand?
No.
Absolutely
No.
not. Right? And what if I multiplied these guys together? What if I took x to the 2nd power times x to the 47th power? Do you guys happen to know what that would be?
49.
Not 49, but you're close. You're just leaving off something that's very important.
X to the 49th power.
It would be x to the 49th power. Right? Because we have 2 x's that have been multiplied here and 47 x's that have been multiplied here. So how many repeated multiplications did we have? 49 total repeated multiplications. And that's going to be stored right there in the exponent. Okay, so some of you guys might be familiar with this, but if you have x to the some power over here, let's just say x to the n power, and then let me back up, did that wrong. We multiply that by x to the m power. Let's say that those exponents are different. Then all you need to do is add those exponents when you multiply this out. Any questions or comments there? We're going to see some examples here on the next slide. So I want to keep us moving a little bit. So multiplying variables can be a little bit tricky, but what you have to understand is this. If you multiply 2 different variables, what we usually do is just stick those 2 letters together. So a times b, you'll see it written as ab, but that's the same thing as a times b. Okay. If I have the same variable, then I can use exponents to shorten or simplify the expression. So c times c is equal to c squared. Are you guys okay with that?
Yes.
And then if I had two different exponents, but I have the same variable, so we have c to the second power and times c to the fifth power, then that should be just add up the exponents, c to the seventh power. If we needed to, we could fall back on our definition for exponents there, because you could say that this is c times c, and this is c times c times c times c times c. And then you could count up all the c's that have been repeatedly multiplied, but it's just easier to add those exponents. That's just a shortcut. Any questions or comments about those examples? Okay. Let's clear that out of the way. Okay. So we often see a lot of multiplication with variables and constants in algebra. So here are just some examples that, on your own time, you can go back to this slide and take a look at it. So example A, if I have a to the third power times b to the seventh power, those are different variables. So if I'm asked to simplify this, all I'm going to do is just write those variable terms next to each other. Right? It doesn't look much different. It's just a to the third, b to the seventh. I just removed the dot and just squeezed those letters together. Okay. But for other problems, they're a little bit more complicated because now we're going to have to combine some ideas like distributing with this idea of multiplying a variable times a constant or a variable times another variable. So we really want to take our time with this until we build up that confidence and accuracy. So looking at example B, I have q squared, and I need to distribute or multiply that by 4. So what is q squared times 4?
4q squared.
Yeah, that's exactly right. 4q squared. Sorry, I messed that up. Let me put 4q squared there. Plus, if you guys are okay with that first multiplication, what's q squared times another q?
2
Just
Squared.
2?
Q to the third.
It's
2 to the third?
squared.
Q to the third.
Q to the third. Q to the third power is correct. Does anybody have any questions or comments there? Feel free to ask. It could even be just a comment like, what? How? Okay, so I do want to clarify that q squared times q is the same thing as, well, how many q's got multiplied here in the q squared?
2.
So that's q times q, right?
Yes.
And then I'm multiplying that by this extra q, right?
Right. So then it'd be
Yeah.
q.
So in total, I should have q to the third power. Does that make sense?
Yes.
Hopefully
Yes.
it does. Okay. So that's why we should get 4q, and damn it, I have a typo in my PowerPoint. That should be 4q squared. So I'm just going to add that on there. And nobody was any the wiser, okay? 4q squared plus q to the third power, that is now correct. All right. This next one gets a little bit more convoluted, right? 5n times n to the third power. What do we need to write down there?
Is it 5n to the fourth?
That is absolutely correct. 5n to the fourth power. Okay, that looked terrible, so I'm going to retry that 4. There you go. 5n to the fourth power. What is 5n times 2n squared?
10n to the third power?
And n to the third power is correct. What is 5n times negative 10n.
Negative 15n squared.
Negative 50. And then
15, 1 5.
oh, 1 5. No, that's not correct.
Oh, negative 50.
Yeah, negative 50 is correct, right? Because it's 5 times 10 or 5 times negative 10, which is going to be negative 50. And then n times n is n squared. So last bit of multiplication is 5n times 7.
35n.
Yeah, 35n. Do I have any like terms?
Yes, all the ends.
Yes.
Ooh, be careful there.
No.
What makes something a
Oh,
like term?
no. No, you don't.
No,
Why not?
they don't have the same,
Because there's not.
They're all different.
they're different exponents.
Yeah, not.
They're all different exponents, all right? So like you don't want to rush to judgment there and say, "Oh, they're all n's, so I can combine them all together." No, they have to have the same variable and the same exponent. So be very cautious when you're doing that. Okay? But otherwise, that's correct. And like, I don't know, maybe some people hate math because in high school, back in the day, you had to work out like a million different problems like this, and they never really clarified why you were doing it. Once we get out of this first homework, um, we're going to see that we're going to put to use some of these ideas, and they're not going to be super like convoluted. Uh, but it's going to be necessary to sort of help simplify our lives because we can't do everything in the calculator. Like we cannot simplify these expressions in the calculator whenever we have a variable. We can only simplify things in the calculator if I give you the variable value, okay? But otherwise, we just need to do some stuff by hand, combine like terms, distribute, and that should be all well and good, okay? So the last bit here, last couple of slides here, introduce what's called function notation, okay? And we're going to discuss functions a lot throughout this semester, but right now we're going to get just a brief introduction. And the way I want you to think about what a function is in math, it's just like a machine, okay? So if you're old enough to remember what it's like to put coins into a jukebox, or maybe back in the day when you could put coins into a vending machine, everything is tap to pay now, so it's kind of hard to use these analogies. But you put a quarter in a jukebox, the jukebox selects the song, and then out comes the song. So you want to think about these functions as you're going to plug something in, usually a number. An equation or a set of instructions is going to do something to that number, and then it's going to spit out a different number. So we have an input value and an output value, okay? That should be easy enough to think about. You put quarters in a vending machine, you get candy out, okay? But when it comes to math, everything looks kind of crazy. We got some letters, we got some numbers, we got some parentheses, and then they just tell you evaluate the function m parentheses x parentheses equals 2x plus 5 when x is equal to negative 4. Okay? And if you say that all out loud, it doesn't make any sense. It's just a bunch of gobbledygook that's in your brain now. None of it stuck. Okay? So when you see a function, you want to focus on this part, right? The function here is, we would call it m is the name of the function. Okay, that is my terrible handwriting. That's the name. And that name can change. Sometimes we put f of x. Sometimes we put g of x, h of x. If anybody here is familiar at all with like spreadsheets, like Excel or Google Sheets, sometimes you use functions like the average function. Let me type this out instead of writing it. You might have an average function that looks like the word average, and then you put something in the parentheses. Okay, but that number, or I'm sorry, that letter or that word in front of the parentheses, that's the name of the function. We don't have to do much with that. But what you do want to focus on is this x value, which tells you what your input is, what you're going to plug into the function. So I'm going to write here, this is the input, It is what you will plug into the function. Okay. And then the stuff on the right-hand side of the equal sign, in this case, this 2x plus 5 business, that's where we're going to actually do some math. Okay. So let's see this example on the next slide. It's the exact same example. Evaluate the function m of x is equal to 2x plus 5 when x is equal to -4. What they're telling you is, sometimes it's written this way, where they put m parentheses -4. This is the way we abbreviate it. But what they're saying is, take this x value, it's equal to -4, plug that into this part of the expression, and then just simplify it or evaluate it. Okay? So all I'm going to do is write down m of -4, and that's going to take some getting used to. So in the parentheses, I'm literally plugging in my -4. Once I do that, then I can start solving the expression or like simplifying it little by little. And I feel like that gave away the secret there. You probably want to see this written out. So I'm going to write this as, it's originally 2 parentheses plus 5, right? Because I said anytime you want to evaluate these expressions, do it with an open set of parentheses first. Okay, so that's your first step. Then you have to remember this is the number that we're plugging in. This is your x value. So we're going to replace that x value here in the parentheses. We'll put 2 times -4 plus 5. And then, for the love of God, use your calculator, right? This one's pretty simple, but when we get like more difficult looking equations, you definitely want to use your calculator on that, okay? What we'll do is we'll then put this into the calculator, or we'll do it by hand. 2 times -4 is -8 plus 5. It should be 3, okay? Not everybody is as fast as math as I am, and I'm certainly not the fastest one there is. But like for you guys, just use the calculator, okay? I can't urge you enough to do that. What's up?
Wouldn't it be -3? Yeah.
Yeah, that's what I said, -3. You all saw it.
No.
Because exactly like I said, 2 times -4 is -8 plus 5 is -3. That's what I said. Okay. Because when in doubt, just gaslight your students. Okay, yeah, I made that mistake, but good catch. Should not be a mistake in the PowerPoint, though. Let's see here. Yeah, there we go. Right, 2 times -4 plus 5 is -8 plus 5, which is -3. Okay. All right. Questions, comments, concerns? So I'm sorry I was a little bit long-winded today. I do want to switch over to this worksheet. So let me go ahead and switch us back over so we can look at Canvas real quick. Stop the share here. Okay. Okay, so I'm going to show you guys where you should be looking here in the Canvas modules. And let me just go ahead and blow this up. View as a student. So this is what you guys should be seeing right now. And I'm trying to do my best to load up some stuff, some in module 1 right now. But for our purposes for today, your homework is going to be this assignment number 1, and then we also have this worksheet that we're about to go over. Okay, so if you just click on worksheet number 1, you should see this worksheet pop up here. Okay, like I said, if you don't have a printer, you can just blow up the worksheet so that you can follow along as we go through these problems. And then you can just hold on to that, file that away, because it's just going to reinforce the things that we just talked about, okay, and give us a little bit more practice, okay? So I have a hard copy of this worksheet. I'm going to switch us over to that. But like I said, if you don't have a printer, then just go ahead and put number 1A, right? And then write down this expression so that we can talk about it here. I'll switch over to my document camera so we can look at this together. Okay. So just to, put a bow on this whole thing, we're going to work through some example problems, and hopefully you guys can help me answer them based on what we talked about today. We got our vocabulary here. We talked about what a constant is, what a variable is, coefficient, and I've said the word terms quite a bit, okay? So for this first set of problems, it says the number of terms in an algebraic expression can usually be counted by looking for the things that are separated by addition or the subtraction symbols. How many terms are there in the following algebraic expressions? So we're not plugging anything in here. We're not evaluating an expression. I'm literally just asking, how many terms are there? Okay, so for this first expression, it's 5n squared plus 12n plus 2. How many terms are in this expression?
3.
3 terms is the answer. Does that make sense? Is that okay?
Yes.
Right? Because I feel like sometimes when I ask a simple question of students, they're searching their brains to try to make it more complicated or think that it's a trick question, but I'm literally just asking you, how many terms are there? So looking at example B, how many terms are there in this problem?
2.
Yeah, 2 terms. And here in the final example, C, how many terms do I have?
1.
1.
Yeah, 1 term. I think it's a really useful skill to be able to identify the number of terms, because when we start getting into module 2, there's a process called factoring, and you're going to learn different techniques for factoring. But one of the factoring techniques can only be used on a 3-term polynomial. Another factoring technique can only be used when you have 4 terms. Okay, so being able to identify and count the number of terms, even though it might seem like the simplest thing in the world, is going to be a really useful skill. And I want it to be very clear when I'm asking for the number of terms, it's just this simple. Does anybody have any question about those problems?
No.
Okay, cool beans. Let's go to the next page. All right. The instructions say, for any algebraic expression, you should be able to classify the terms as either a variable term or a constant term. For the following expressions, identify the variable term and the constant terms. For the variable terms, label their coefficient. Okay. So I think the easiest way to do this is just going term by term. This first term, is it a variable or is it a constant?
Variable.
How do you know?
Because of the y.
Because of the y, right? So that's a variable term. And what is its coefficient?
4.
Coefficient 4. I'm just abbreviating coefficient as coef. Okay, so if you put that down, I'll understand what you mean. And then we move on to the next term. Is this term a variable term or a constant term?
Variable.
That's a variable term. And what is its coefficient?
1.
1.
Sounds good to me. I'm making light work of this, right? Finally, we have 22. Is that a variable or a constant?
Constant.
That's a constant. And constants don't have coefficients, so we're not going to label anything there. Any questions, comments, concerns about those?
No.
Okay. Sounds great. You guys want to do one more? Or does that seem easy enough?
Can I show
One
you
more.
how I did it? Would this be okay?
Yeah, if you want to go ahead and share your screen, let me stop my can I stop my share?
Is it going? Oh,
Yeah.
wait a minute.
Yeah, can you
Oh,
share your
boy.
screen right now?
Right now it's asking me if I try to show my video and then it just like asks me if my video, like, would you like to wait or would you like to close the program?
Oh,
Okay,
that's
there we
interesting.
go. So I have like on the side, like what the variable is, and then would that be
Oh,
okay?
yeah, I think I know what you're talking about. Let me go ahead and go back to my document camera real quick. So like I'm just drawing arrows and pointing to that. Like I think that's good enough. But if you're going over here to the side and saying, 7x to the fourth for this next one, and you're saying that's a variable term, and then the coefficient is 7 or something like that, that's perfectly fine.
Yeah.
Yeah,
Yeah.
I understand that. That's fine.
Okay.
Again, there's not a whole lot of room to like write a bunch of stuff, so that's why I'm just drawing arrows and just trying to make this a little bit easier. Let's go to the next term. Is this a variable or is that a constant?
Variable.
Yeah, I mean this isn't too hard, right? I sometimes am afraid of saying like, oh, this is pretty easy, right? Because like maybe for some people out there it's not so easy, and I want to be sensitive to that fact. But are you guys seriously okay with this, or is anybody out there just like worried to all hell, and they think that this is going to be the most complicated thing in the world? This is okay?
I'm good with it.
Yes.
Okay. And then finally, we can go over here and say that 49 is what?
Constant.
Constant.
Yeah, constant. Okay. And then one thing I'll say about this last problem is that it doesn't matter whether that number in front of the variable is a fraction, a decimal, or what have you. That's the coefficient. Okay. So like this is a variable term. Its coefficient is 2 over 3. Okay. You might not know what the decimal form of 2 over 3 is, or you might be afraid of fractions, but like that doesn't matter right here. You're just going to say, this is a variable term. The coefficient is 2 over 3. This is a variable term. Coefficient is what?
1/2.
1 over 2 or 1/2. This is a constant term, so we don't have to worry about coefficients there. Does that make sense?
Yes.
Yes.
Okay, at the bottom of that worksheet, I just put a note here just to remind you that if you ever see a variable that does not have a number in front of it, the understood coefficient is 1. Okay, so let's get to the next few problems here. We have 3 more. We actually have 3 more and then 4 more on the next page, but we're making light work of this, so it's not that big a deal. This one says, for any algebraic expression, you should be able to simplify the expression by using the distributive property or combining like terms. Just some extra practice here. So can you guys tell me by looking at this first problem, do I have like terms that I can combine?
Yes.
Yes.
Yeah, which ones are they?
2z and -8.
-8z.
Okay, so what is 2z minus 8z?
-6z.
So I have -6z. And then do I have some other like terms I can combine?
7 and 6.
Yeah, I can take this 6 and this 7. They're both constants. So in the PowerPoint, we were talking a lot about combining like terms when they had the same variables. But if they're just constants, let's just combine them because those will be like terms, right? So what's 6 plus 7?
13.
13.
Yeah, so I'm just going to put plus 13 here, and then that is my final answer. A lot of times when
Quick question.
yeah, go ahead.
Did you want us to box it how you just did, like the answer, to make it clear?
Yeah, I think that if you box in your answer, it definitely makes it a lot clearer for me, especially if you have a lot of scratch work.
Okay, got it. Thank
Yeah. Thank you. That was a great question. Okay, so this next problem here, what are my like terms?
The 2x squared.
So I have 2x squared here. And what's my other x squared term?
2x squared. Or -2x squared.
-2x squared.
So what is 2x squared minus 2x squared?
0.
0. So I'm going to put a 0 here for now. But I'm sure that a lot of you guys are thinking like, oh, I don't have to write that 0 down. And that's true. But I'm going to write it down right now as a placeholder. Let's continue combining like terms. What's my next set of like terms?
3x and 5x.
So what's 3 plus 5?
8.
So that's going to be a positive 8x, right? And then I just have this lonely negative 4, right?
Yep, -4.
So I'm just going to put -4, okay? Well, now that I have this 0 here, that's a constant. And I have this -4, which is a constant. So you could think of this as 0 minus 4, or you could just say to yourself, if anything zeros, if I combine like terms and I get a 0, those just cancel out, okay? We're sometimes lazy when we use this expression cancel out, but what we really mean in this case is that it cancels out to 0. So you don't have to write this 0 down. You can just write 8x minus 4, and that is fully simplified. Any questions or comments about that one?
No.
Okay, for this, I was gonna say letter C for this last problem. What are my like terms and what do I need to combine?
There's
That's
no like
fine.
terms.
Yeah. So here, there are no like terms and there's nothing to distribute. Actually, none of these problems required to distribute a property. But this is a to the third power. This is a to the second power. Those are not like terms. And then we have a constant. So there's nothing to combine. So you could either write down nothing to combine, or you could just leave it alone and say, this is just 13a to the third power plus 7a to the second power minus 25. And that's the final answer because you can't do anything there. Okay, so you do need to watch out. I'm not sure if in the Alex homework you'll have something like that, but if you can't combine something because we don't have like terms, don't try to force it. For the love of God, stop. Okay, walk away. Any questions, comments about those combining like terms problems?
No.
Okay. Just a vibe check. Does this feel pretty doable?
Yes.
Yes.
Okay. All right. It's not going to feel that way forever, but let's enjoy it while we have this moment of ease. Okay. These last problems are actually going to have you do some math, and I'm going to pull up the calculator to do that. So let's read the instructions. It says, for some algebraic expressions, you will be given the variable values to substitute into the expression so that the entire expression can be evaluated. Evaluate the following expressions. So here we have 2t squared minus 4t plus 10. Given that t is equal to 3. So what's the first thing that I have to do here?
You have to plug in a 3.
Plug in that 3.
Plug in that 3. So when we plug it in, remember, if you're not used to writing this stuff down, then what you should do is I always write an equal sign before I start this kind of thing. You don't have to write the equal sign, but you should write 2 parentheses squared minus 4 parentheses plus 10, right? Because the variables are placeholders, and so we're using the parentheses as placeholders now so that we can plug in t is equal to 3. So I'm going to put a 3 here and a 3 there. And it looks like, Audrey, you typed that beautifully into the chat. So you can evaluate this by using your order of operations, but I said, ain't nobody got time for that. We got our calculators. If you type this into the calculator exactly the way you wrote it down, then you shouldn't have an issue. So I'm going to put 2 parentheses 3 squared minus, that's the subtraction button, 4 parentheses 3, close the parentheses up, and then put plus 10, right? So that should look exactly like what I wrote down. Hit enter, and I'm getting 16. Okay. So you put 16 down. Sometimes you just gotta let go and let God. Hopefully you type that into the calculator correctly. And then you type that into, like if this was on Alex, you would type that into the computer and then you hold your breath and hopefully it gives you a green check mark. Okay. But it should be that painless. Okay. You do not have to go through the process of saying 3 to the second power is 9. Then we have to multiply that by 2. And then we have 4 times 3. So this is like an example of what not to do. I mean, you could do it, but I just think you guys have better things to do with your time. This will be 18. This will be 12 plus 10. 18 minus 12 is going to be 6 plus 10, which gets you back to the 16. But the calculator did it for us, so why are we wasting our time with that? Right? We got bigger fish to fry. So get used to using that calculator. Okay. The next one says we have 5p to the third power minus 25p. So that's going to be 5 parentheses to the third power minus 25 parentheses. And then what are we plugging in?
-2.
We're plugging in -2. And then what are we doing?
Plugging that into the
Plugging into
calculator.
the
We're plugging
calculator.
that into the calculator exactly as we wrote it down, right? 5 parentheses, -2, close up the parentheses. Now we need that caret button to get an x to the third power. Sometimes your calculator stays up here stuck in the exponent, so just be careful about that. If your cursor is still hovering by the exponent, just hit this arrow to go down to the side and make sure that that cursor has come down. Then we'll hit subtract 25, parentheses -2, close up the parentheses, and that should be exactly what we wrote down. Okay. We hit enter, we get 10, and then we move on with our lives. Does anybody have any questions, comments, or concerns there?
No.
Okay, cool beans. All right. This one's a little bit more complicated, so I'm going to write this down as 5 parentheses 2. This seems weird. I have an x there. I need another set of parentheses. Okay, so that's 2x minus 7. Then we close up the parentheses there. Minus 2x. God damn it. I didn't mean to write the x.
Parentheses.
I can't talk and write at the same time, clearly. Definitely don't use pen unless you got some whiteout on you. There we go. That was -2x to the second power, right? Okay, so what are we plugging in for x?
0.
0.
0. Okay. Now, even though this looks complicated, and you might, try to solve this on your own by using your order of operations, you can type this into the calculator. Exactly as we wrote it down. 5, parentheses 2, parentheses 0, close parentheses, -7, close parentheses, -2, open parentheses 0, close parentheses to the second power. And then I get -35. Isn't that easier than doing your order of operations? Because
Most definitely.
if you didn't have the calculator, again, you can do it the long way, but you have to say, okay, do my parentheses first. So 2 times 0 is going to be 0. That's 0 minus 7 times 5 minus 2 times 0 squared is 0. So I've taken care of the exponent. Need to take care of this parentheses. That's going to be 5 times -7 minus 2 times 0 is going to be 0. This is going to be -35 minus 0, which is -35. Right? Nobody has time for all of this mess. Okay. Finally, this one says f of x is equal to 2x squared plus 3x minus 5. Okay. So I only care about this expression part. I don't really care about this f of x. If you want to, you can write because they're telling us x is equal to -5, we're looking for f of -5. That's the abbreviated way that mathematicians write things down. But once you have those instructions, this is just saying, hey, plug in -5. Okay. So once you understand that, go ahead and plug it in. We'll do 2 times -5 squared plus 3 times -5 minus 5. And then what do we do?
Calculator.
Put it into the calculator, guys. Okay. 2 parentheses -5 squared plus 3 times -5 minus 5 should be okay. Somebody popped out of the Zoom session. I'm going to let him back in. There we go. So like I said, what you wrote down, if you're careful about how you write it down, if you're careful about how you type it in, should be good. We should get the number 30 as our answer. And so we can move on with our lives. Okay. Any last questions, comments, concerns about this problem or about anything that we talked about today?
Question. So
Yeah.
I read from the syllabus, one of the questions was for the quiz was that you can adjust our grade on our test by the stuff that we write. So by
Yeah.
that you mean if we like just make an error and plugging in one of their numbers or forgetting to convert a positive to a negative, do you deduct points from that? Like when we're
So the way the tests go is that the tests are automatically graded by Alex, right? So as soon as you're done with the test, you're going to know what you got right and wrong. But I have you guys submit, like upload your handwritten work so that I can review it because like I have to review the quality of your work in order to assign a final grade for those tests. What I mean by that is sometimes there's a couple of things that happen. Since the test is going to be on Alex through the computer, sometimes students write the correct answer down on paper, but they type the wrong answer in, right? Maybe they forget to type a negative sign, or they just kind of like type the wrong key, right? But they did the problem correctly, and they got the correct answer on paper, right?
That's happened to me.
So I want to be able to look at your work to say, oh, they actually knew what they were doing. Even though Alex counted them wrong, I'm going to give them those points back. Okay.
Thanks.
So that's one thing.
That's kind of what I figured. I was like, let me ask him since he's asking about questions.
Yeah. The other thing is that sometimes, like for these, I'm telling you guys, you can just write out the problem, substitute your answer in, and as long as you write that down and then box in your answer, I know that you've done that with the calculator. Okay. And that's fine. But later on, we're going to be doing some processes that you can't do with the calculator. And if you're skipping too many steps, or if, things are starting to look like, hey, this looks like ChatGPT did this work, or it looks like the student typed this in the Mathway and then wrote down the answer, then I have to say, I don't think you showed enough work here. I'm going to have to deduct some points. Okay. But that really pertains to the more complicated things that we're going to get into in Module 2 and Module 3. Because you will have to show and explain how did you get your answer, because it's not going to be as simple as, oh, I just typed it in the calculator. Does that make sense?
Yes.
Yeah, so as we do things that are more complicated and require multiple steps, you're going to have to show those critical steps, and I'm going to want to see them. And if you're neglecting because you're telling me, oh, I just did that in my head, oh, I just did that in my head, at a certain point, I'm going to get suspicious because some of those things are so complicated that you cannot do all of it in your head. And I say that because there are some processes that I can't do completely in my head. Just as a scary preview, eventually we're going to be working on some problems that might require you, for the single problem, it might take an entire piece of paper. Okay. It might take a page and a half to actually work out the whole problem. Okay. But we're going to build up to that. Baby steps on the way there. We're going to take a couple of big jumps here and there, but we'll work our way up. Right now, I'm not too worried about it, but I will tell you guys a little bit more as we get closer to the test. What do I expect to see as far as like the quality of your work and how I want you to format those things. I wouldn't worry about it too much right now, but for evaluating equations or evaluating these functions, just plug and chug, let the calculator do the work for you there, and I'll understand what you're doing there. Any other questions, comments?
Sir, I had a question.
Yeah, what's up?
So for us that did it on scratch piece of paper, did you want us to just scan it and then send it through Canvas?
Yeah, absolutely. So if you worked this, and let me go ahead and actually share what Canvas looks like from a student's perspective, right? So if you did this on your own sheet of paper, that's perfectly fine. When you get to this assignment in Canvas, you'll click on this button that says Start Assignment, and then it allows you to upload that, right? And so this is why in the orientation module, I had you guys use Google Drive to learn how to scan a drawing. And a lot of you guys drew really nice pictures of superheroes and animals and stuff. But really, if you have multiple pages that you're scanning of your math work, what I want you to do is using Google Drive, take a picture of each of those pages. Google Drive should be compiling those into a single document that has multiple pages. So for instance, if you use your own paper here, you might have just used the front page, or you might have just used front and back, right? That'd be perfectly fine. But like if you actually downloaded and printed this document, it's 4 pages, right? So you would have to take pictures of every single page, 1, 2, 3, 4. And then you'll upload that one document, that one PDF document that has all 4 pages, okay? So you'll go here, you'll choose that multi-page document, and then submit the assignment. It should show you some confetti when you do it, and I think if you're using your phone to do it, it should say that it's uploaded. But if you're struggling with that, you can bring it up to me tomorrow, and I can try to help you troubleshoot there a little bit. But yeah, just upload that using Google Drive, and the Canvas for Students app makes it super easy to upload things from your phone. So if you need some assistance with that, I can assist or troubleshoot as best I can from Zoom. But yeah, you'll upload that here.
Okay, thank you, sir.
Yeah, I was like, man,
Sure.
that answer was long as hell for just a yes. Okay, I heard a question. What's up?
So I typed in like the work
Okay,
and I used the calculator and I
okay.
just take a picture of the problems and just put it to Google Drive, convert it to a PDF and just dump it on Canvas.
Yeah, that'd be fine with me. As long as you can make it
Okay.
as take those images as that PDF and upload it. Yeah, that'd be fine.
Okay, because I just didn't want to do like a half-ass job.
No, that's okay. Definitely be careful when you guys are taking these pictures. Sometimes students take pictures of documents and they're like, the piece of paper is in their lap. So I see like the work they're turning in, but also their thighs. Just be mindful of where you're taking pictures of things. And also, if you're going to do that, please have like pants on and not like booty shorts.
My goodness, that's too much.
You think
Are you
I don't
actually
have
being
to
for
say
real
these
with that?
things. You think that I don't have to say these things, but some students just forget. I've had students that took a test, and they took a phone call during the test that was being recorded. So when I went back to watch the video, I was like, why are they talking on the phone with their friend for an hour during this test?
Isn't
Um,
that like not allowed?
yeah, exactly. I gave them a 0 on that test for sure. You shouldn't do that. Um, But also, why wouldn't you just take the call before you started the test? Anyway, not that point's neither here or there. Just if you're going to take images of things, oh man, here's one other thing. I had a student a couple semesters ago that she would take pictures of her work and it would be all blurry, but like she would put the paper down on like a tray where she had rolling papers and weed on the tray. She had like blunt
Weed?
wraps. And I was like,
That's crazy.
how are you gonna snitch on yourself by like sending in a picture of like your math homework with like a blunt next to it? So again, you think I don't need to say this, but you would be surprised. Okay. So just, put it down on a nice surface that doesn't have anything on it. Take those images and make sure that they're legible and I can read them. Okay. Any other questions, comments, concerns? I'm sure that you guys are itching to get out of here. Okay. Well, if you have any questions that you're holding off until everybody leaves, uh, you're free to hang out with me for a couple more minutes and get those questions answered. Otherwise, I'll see you guys tomorrow. Hopefully, it won't be so long.
Okay, good night. Thank you.
Good night, y'all.
Quick question.
Yeah.
Just to reiterate, you had said variables are placeholders and placeholders are the parentheses.
Yeah.
Okay. Just making
Yeah.
sure.
So like I use the parentheses as a placeholder, basically just as a loading, like a loading dock, right? Because we're going to put a number in there eventually. So when I start off those problems, I think that we like to practice safe math here. It's safe to just set up those parentheses and then figure out what number goes in later. And then usually that makes it cuts down on some issues with like little mistakes.
Thank you. Have a good night.
Got it. You too.
Pleasure.
Take it easy, y'all.